Good morning. This is Ms. Billerbeck, and we are going to talk about 7.2 multiplying polynomials. So we have Leonardo, and he had to paint the ceiling of the MoMA, the Museum of Modern Art. So he sketched a small version and needed to calculate how much paint to buy. So this is a sketch. He sees that there's a 40-foot stretch here, and he wants to have some proportional corners here in purple, and then a section here in red, and the middle of the ceiling to be green. So he's looking at how to go about calculating the best proportion, and he wants the most flexibility, so he keeps this as a variable. So we see we have this square here, and the area is length times width, which is x times x. So the area of the purple square is x squared, and there's 4 of them. So we have 4x squared for the purple. Now let's look at the red ones. So we have a width of 2x and a length of x. So 2x times x is 2x squared. But we have 2 of them, so we're going to put 2 times 2x squared. Then we need to deal with the center section of the white paint. So to find the center of the white paint, we have 40 feet times this x here. So this section of white would be 40 times x, and there's 2 of them, so we're going to put twice 40 times x. Now our last bit of paint is going to be 2x is the width right here, 2x times 40. So we have 2x and then times 40. So when we straighten this up, we see we have 4x squared plus 4x squared is 8x squared. And we have 2 times 40 is 80x, and 2 times 40 again is 80x. So 80 plus 80 is 160x. And that's what we have as far as total paint. So that's the area of total paint. So just for budgeting, you can figure out the cost of paint in area, and then apply this to figure out how much total paint will be required to do this job. All right, so let's take a look at the tools of multiplying polynomials. So we have the distribution tool. So we can distribute that negative 2x squared to all 3 of these terms in the trinomial. So a monomial times a trinomial. So we're going to write negative 2x squared times x squared, and then plus negative 2x squared times 3x plus negative 2x squared times 4. Now we see we're going to have a plus minus, so we don't need to write plus minus. We'll just write a minus. So we have negative 2 times, and this is x squared times x squared, so same base, so we add the exponents. So we have negative 2x to the 4th minus, and this is 2 times 3 is 6, and this has a 1, so 2 plus 1 is 3. So we have 6x cubed, and then we're going to have a plus minus situation here, so we'll put minus again. And 2 times 4 is 8x squared. So that would be our answer doing distribution. Let's try a different method and see how it might work. So we can always use the box method. where we have negative 2x squared here, and we do areas of boxes. And we just write what we have on top right there. So negative 2x squared times x squared is negative 2x to the fourth. Negative 2 times 3 is negative 6, and x squared times x to the first is x to the third. And negative 2 times 4 is negative 8, and we just have x squared. So we see we have the same thing, negative 2x to the fourth minus 6x to the third minus 8x squared. Okay, so those are two different techniques you can use. The box is a very nice way to visually sort it out versus doing a bunch of parentheses like this. Okay, so let's try the box method with this one, since it's one of my favorite methods. Okay, so we have 2x squared. This is a minus 3x, and then a plus 5. So negative 4 times 2 is negative 8, and that's an x to the first. So I have x to the first times x squared is x cubed. Then negative 4 times negative 3 gives me a positive 12. And I have x to the first times x to the first gives me x squared. And then negative 4 times negative positive 5 is negative 20, and we just have an x. And we do not need to write the 1 with the x. It's just understood that there's a 1. So then our answer then would be negative 8x cubed plus 12x squared minus 20x. And again, you could have just done distribution to do the same thing. So this would be negative 8x cubed, positive 12x squared, and negative 20x. All right, so let's continue with the box method. So we want to find the area of each rectangle. So if we look at this, we can see, well, we'd have an area coming down like this and an area coming down like this. So we're really looking at what is this area here and what is this area here, this area, and this area. So let's call this area 1, 2, 3, and 4. So area 1 is just going to be 2x times 5x. So the 5x is right here, the 2x is there. Area 2 then is 4 times 5x. Area 3 will just be 2x times the 2, and area 4 will be 4 times 2. So when we multiply this, we get 10x squared, and this will be 20x and 4x, and then we get 8. All right, so these two are like terms, so we can combine those, but these two are not. So this would be a 24x right here. So area total then would equal 10x squared, and 20 plus 4 is 24x, and then plus 8. So that's one way to organize it. Okay, so if we do it this way, we can all right, and we have area 1, area 2, area 3, and area 4. So we're going to add it all together, and we get the total amount of green area. So let's take a look at area 1. That's 7x for this length, and the width is 2x. Area 2, we have 2 times 2x. Area 3 equals the 7x times just 1. And area 4 equals 2 for this length here times 1. So when we multiply that out, 7 times 2 is 14, and x times x is x squared. 2 times 2 is 4, and we have an x there. And then the 7x times 1 is the identity, so it's 7x. And 2 times 1 is also the identity, so we have 2. So the only 2 like terms are those 2, which gives us 11x. And so our area total for the green area would be 14x squared plus 11x plus 2. So that's the total for our smaller rectangle, and that would be the total for our larger one. All right. So let's add a new tool to our toolbox. Let's talk about when we multiply binomials, we can do a type of tool called FOIL. FOIL is basically just distribution. Okay, you can see the little distribution rainbows going on here. FOIL is distribution, but it's in an ordered way. So FOIL stands for first, outer, inner, last. So first we multiply 3x times 2x, the first terms of the two binomials that we're multiplying. So we have 3x times 2x. Outer is the outside term of the binomial times the other outside term of the binomial. So 3x times 5. Inner are the two that are right adjacent or next to each other. So we have -4 times 2x, -4 times 2x. And then the last terms of the binomial are -4 and 5. So we write -4 and 5. So now when we multiply that, we can get our answer. So 3 times 2 is 6, and we have x times x gives us x squared, plus 3x times 5 is 15x, plus, and -4 times 2 is -8x, so we can just subtract 8x, and then -4 times 5 is -20. So we have two like terms right here and right here that we can combine. So we have 6x squared plus 7x minus 20 as our final answer. So that's how we'd use FOIL. So we're going to find each product of a binomial by a binomial using FOIL. So we're going to start with first. So we have 5x times 2x. Then the outer ones, 5x times 1. Now the inner ones, so we have -4 times 2x, and the last ones, -4 times 1. So that gives us 10x and x times x is x squared, plus that's just 5x. And then we have negative 4 times 2 is negative 8x. And then negative 4 times 1 is negative 4. Again, we have in the middle, when we do FOIL, our two like terms are usually right next to each other, or always. Well, sometimes they're not, depending on if this one has an exponent and that one doesn't, or they differ. So typically the middle terms are similar, so be careful to look for the common terms or like terms there. All right, so then our final answer then for this one is 10x squared, and then 5x minus 8x is negative 3x minus 4. So that would be our answer for that one. All right, let's try that for this one. So we have first 3x times 2x outer, which is 3x times 4 inner, minus or plus negative 5 times 2x and negative 5 times 4. So when we multiply this out, we get 3 times 2 is 6, and x times x is x squared, plus, and 3x times 4 is 12x, and negative 5 times 2 is negative 10, and there's an x, and negative 5 times 4 is negative 20 again. So we have 12x and minus 10x, so those are our like terms. So our answer then will be 6x squared, and that'll be plus 2x minus 20. Okay, so there is another way we can do this, and it's a preferred way for many people is to do a box, much like the earlier examples. So we just make a nice little box like that, and we can write the 5x and the minus 4 here, or the 2x and the 1 here. Okay, so 2x times 5x is 10x squared. So that gives us the area for this box. 2x times negative 4 is negative 8x. 5x times 1 is 5x. And negative 4 times 1 is negative 4. So we see, oh, hey, the diagonals are the same. So our like terms are right there. So we have 10x squared, 5x plus negative 8x is negative 3x, and the minus 4. So we can do the same thing with this binomial. So we have 3x, and it doesn't matter if I put this one on the top or on the side, so don't worry about it. The commutative property of multiplication says you can put it here or you can put it here. So we have 2x and then plus 4. So we have 2x times 3x is 6x squared. 2x times negative 5 is negative 10x. And 4 times 3x is 12x. And 4 times negative 5 is negative 20. So again, our like terms are on the diagonal. So we have 6x squared. 12x plus negative 10x is 2x, and negative 20. So this way, again, is rather simple than extending it out like this, but you should be aware of both tools. They're both very handy. All right, so now we're going to try a new tool. So we want to find the product of a trinomial by a binomial, like multi-digit multiplication. And then we're going to use the box method, which is much easier to use. So what I'm going to do is I'm going to take negative 3x squared and do plus 4x and minus 7. And then I'm going to multiply this trinomial by this binomial. So I have multiplying by 2x minus 5. So how we go about doing that is this line, we're going to multiply 5 times negative 3x plus 4x minus 7. So 5 times negative 5 times negative 7 is positive 35. Negative 5 times 4x is negative 20x. Oops, that's a negative right there. Okay, and negative 5 times negative 3 is positive 15x squared. Okay, so now let's set up this one. So we're going to multiply by, oh, that's terrible to have a multiplication sign that looks like an X, huh? So we're going to put multiply. It's one of those strange things that a multiplication sign looks just like X. It's like, so confusing sometimes. So we have 2x and then negative 3x plus 4x and then minus 7. So we're going to put like terms right under each like term. So we have 2x times negative 7 is negative 14x. And 2x times 4x gives me 8x squared. And then I have 2x times negative 3x squared gives me negative 6x cubed. All right, I'm going to make a little room here so it looks nicer. So we're going to scoot this one right like this. And then that was 2x here. That was 8x. These two, and then this was negative 6x cubed. All right, so now we can add it all together. So we have 35, which is negative 35. We're adding two negatives together, so same sign sum. So that's negative 34x. Then 15x squared plus 8x squared gives me 23x squared. And then I have minus 6x cubed plus 23x squared. So there we have it, the answer. Yikes, wasn't that kind of scary hard? Okay, so let's do it the box way. Okay, so the box way is very easy on your eyes. And we're going to set this up into a trinomial times a binomial. So we put the binomial on the side where there's only 2 rows and the trinomial here. All right, so this is negative 3x squared times 2x is negative 6x cubed. 2x times 4x is 8x squared, and 2x times negative 7 is negative 14x. So negative 5 times negative 3 is positive 15x squared. That's negative 3x squared there. Negative 5 times negative 4x is negative 20x, and negative 5 times negative 7. Oh, how dare I forget to make that a positive. I did it earlier. Okay, so 2 negatives make a positive. So that's why this is a tad confusing trying to keep track of things. Okay, so then the other wonderful thing about this is if you have this an ordered polynomial here and here, you can go ahead and find your like terms on the diagonals again. But this time you might have two different sets of like terms like this. So now we write our answer as negative 6x cubed. Then we have 15x plus 8x gives us plus 23x squared. And negative 20x plus negative 14x is negative 34x. And then we have plus 35, which I've run out of room to write. So I will write plus 35. So that's the answer. So it is the same thing. Okay, and maybe you see why I like this method so much. So let's try this again. We'll use the books method of doing it. And then we'll go back and do the box. Just so you have a chance to see the multi-digit method in action with letters, with polynomials, that is. So we have 2x squared plus 3x minus 4, and then we're going to multiply negative 3x squared plus 1. So our first line here is going to be 1 times 2x squared plus 3x minus 4. So that just is the identity. So we just write what is there. Okay, the next line, we're going to be shifting things over. So we have negative 3x squared times 2x squared plus 3x minus 4 again. This time we have to shift to get it to land right underneath the like term. So when we add them together, it's already done for us. So we have negative 3x squared times 2x squared is negative 6x squared. So we have to move way over here. In fact, I think I'm going to move everything over just to make sure I have lots of room. Okay, so negative 3x squared times 2x is negative 6x squared, x to the 4th. Oh my goodness, we're way out here. Negative 6x to the 4th. You see, x squared times x squared is x to the 4th. And negative 3x squared times 3x, well, that's negative 9x cubed. And then negative 3x squared times negative 4 is a positive 12x squared. So see how I have the like terms lined up here? So I have the x squared with the x squared, so I can add easily. So now I add the two together, and I have negative 4, 3x that drops down. This is 14x squared. Then I have negative 9x cubed and negative 6x to the 4th. All right, so let's see what the box will bring. All right, so we have negative 3x squared and plus 1 right here. Box got a little bit messed up here. Let me straighten that out. Okay, and then we have 2x squared plus 3x minus 4. So we have 3x squared, and you might not be able to read that well. So let me write that nicely, x squared. So negative 3x squared times 2x squared gives me negative 6x to the fourth. Negative 3x squared times 3x squared is negative 9x cubed. Negative 3x squared times negative 4 is a plus 12x. Then I have 2x squared times 1 is 2x squared. 1 times 3x is just plus 3x. And 1 times negative 4 is just negative 4. So we scan for like terms. We see, well, we have some on this diagonal right here. So something's a little, oh, that's why that is not a like term. Ooh, be careful with the exponents. You see how I almost made a grave mistake there? All right. So don't lose an exponent. It can cause great problems when combining like terms. So that's a square right there. So we had a plus 3x and a minus 4. So now when we look at like terms, we have different like terms. Okay, so we have 2x squared terms. We have this term is like this one. They're not quite lined up anymore on the diagonal like normal. Okay, so that's because we're skipping a term right here. There's the x term missing, okay, versus it's here. Okay, so that causes some trouble with our order, and our nice little diagonal like terms are not there. But we can combine these two. So if we take the full area of this rectangle, we have negative 6x to the fourth, negative 9x cubed. We combine 2x squared plus 12x squared is plus 14x squared plus 3x, and then the minus 4. And when we compare that to what we got with the multi-digit polynomial construction method, we have the same thing. Okay. Personally, I think this is the most wonderful way to organize when you're multiplying polynomials. Just saying. Okay, so let's talk about some theoretical things. So why is the operation of multiplication closed over the set of polynomials? Well, let's take a look at our multiplication. So we see, well, we have a polynomial here and times a polynomial here. And when we're adding our exponents, they're all whole numbers. So the whole number set is closed in addition. So when we multiply, that would mean that polynomial multiplication would be closed in multiplication, because when you multiply, you're just adding exponents. So if the exponents are already whole numbers, then you can't get anything else but whole numbers. So it would have to be closed. Okay, so why is it important that the product of two polynomials have only whole number exponents? Well, the definition of a polynomial is a monomial, or the sum of or difference of the two or more monomials or terms. So in order to be a monomial, you have to have a whole number exponent. So if you're multiplying whole number exponents, again, whole numbers are a closed set. You cannot multiply two whole numbers and not get a whole number. So if we're multiplying polynomials, our exponents will be adding. So adding whole numbers is also a closed operation. So we're still going to get a whole number exponent. So you can't have a fractional exponent, because as soon as you have a fractional exponent, it's not a polynomial anymore. So there's just so many things wrong with with multiplying or the product of two polynomials, there's no way to get a fractional exponent, which would violate the definition of a monomial. All right, our last example. Yay. Okay, so what expression represents the area of the phone surface not occupied by the screen? Okay, so yes, there is a little button here that you push here. Okay, so this is a phone. It's a Miss Billerbeck phone. Okay, so if we have the total area of the box is going to be the outside dimension here times the outside dimension here. So total area is going to be this binomial x plus 1 times 1.9x plus 3, and we're going to remember it's centimeters, okay? But the area of the screen, which will be AS, is going to be just x times, so x is from here, this little part here is the x. So it's going to be that distance here times the 1.9x. So x times 1.9x. Okay, so let's figure out what we have. So if we want to do a box, we're welcome. Here, let's do a quick box here to organize things, or you can do FOIL. It's up to you which one you like best. So you have x plus 1 and 1.9x and 3. So this gives me 1.9x squared. This gives me 1.9x. And then this is just 3x and this is 3. So my area here then is 1.9x squared. And then I can combine these two because they're like terms. So I get plus 4.9x and then plus 3. So that's the area of the total phone here. All right, so now this one is x times 1.9x, which is 1.9x squared. Now, if we want just the area, without screen, that's going to be a total minus area of the screen. So we're going to subtract these two. So when we do so, we're going to just subtract 1.9x squared from 1.9x squared. So this is going to equal 0 here. So it's just 4.9x remains when we drop it down. And this drops down, so plus 3. And then this is centimeters, so we can't forget it's centimeters squared. So that is the area of the phone that is not part of the screen. So not very much of the phone is not part of the screen. And that's it for multiplying polynomials. I hope you have a wonderful day. Bye-bye.